Hi guys, today's our topic is cardiac and smooth muscle in comparison with the skeletal muscle. So we know that cardiac muscle is a functional sensation. What does this functional sensation means? So every muscle in the heart will be simultaneously stimulated because of gap junctions, and we call that as electrical coupling. So there is electrical coupling in the cardiac myocytes, so that if you stimulate one myocyte, entire ventricular muscle will be activated. So it works as functional sensation. And in skeletal muscle there is a T tubule with two longitudinal tubules or cisternae. We call this system as triad. But in cardiac muscle it will be one T tubule with one cisternae. We call that as diad. And the T tubule is located at Z line. In a sarcomere which is present in between two Z lines, the T tubule will be present at the Z line. Whereas in the skeletal muscle, it will be present at the junction of I and A bands. One T tubule in each sarcomere. So in cardiac muscle, there will be one T tubule in each sarcomere. And the action potential in the cardiac muscle is 150 to 300 milliseconds. Usually the action potential in the cardiac muscle is a plateau type, which is having a longer duration, whereas it is only 5 milliseconds in skeletal muscle, which is a spike potential. Coming to the release of calcium and the source of calcium, action potential on the muscle membrane activates the dihydropyridine receptor in the cardiac myocyte, and that causes the calcium influx from the ECF. And this calcium influx will cause calcium induced calcium release from smooth sarcoplasmic reticulum, and that is called as calcium spark. So large amounts of calcium will be released. Coming to the smooth muscle, there are some special features for the smooth muscle, that it doesn't have any T tubules. Instead of T tubules, it has pits called as caveolae. And the sarcoplasmic reticulum is not much developed. So the source of calcium is not sarcoplasmic reticulum, it is ECF. And there are no Z lines, so in the place of Z lines will be having dense bodies. No troponin, so the regulatory protein calcium will go and bind to the C component of the troponin. The troponin is absent in the smooth muscle. And the resting membrane potential of the smooth muscle is unstable. It varies from -60 to -40 millivolts. So it is unstable, means it is self-excitable. So it goes towards the threshold, a slight stimulus, it will shoot up. And the duration of the spike potential will be 10 to 15 milliseconds, whereas the duration of action potential with plateau is 1000 milliseconds. So the action potential duration is longer, up to 1 second in smooth muscle. And even the smooth muscle can be activated, or the calcium channels can be activated without the action potential. It can be done by a ligand. So a chemical can open the gates, so we call that as pharmacomechanical coupling. So pharmacomechanical coupling is seen in smooth muscle. If you see here, this is the relaxed smooth muscle and this is a contracted smooth muscle. The smooth muscle contracts like a corkscrew, and the contraction length will be much more. That means it contracts to greater extent than skeletal muscle. And there are two types of smooth muscles, single unit and multi-unit. What is single unit is, every smooth muscle cell is connected to the next smooth muscle cell with the help of a gap junction. So if I stimulate this smooth muscle cell, the entire smooth muscle works as a syncytium. So due to the presence of gap junctions, it acts as a individual, whole muscle will act as a single group. Whereas in multi-unit, each smooth muscle is not connected to each other, so individually they will be excited by different nerves. So no gap junctions, and it acts as a multi-unit. So our visceral smooth muscles are an examples for single unit smooth muscles, whereas iris and ciliary muscle which are present in the eye are multi-unit smooth muscles, and the single unit are self-excitable and the multi-unit is not self-excitable. It is excitable only with the stimulus. And coming to the contraction of the smooth muscle, first the smooth muscle is activated, then calcium is influxed. So the source of calcium here is ECF because sarcoplasmic reticulum is not well developed. Then once the calcium influx, then it binds to calmodulin. So calcium calmodulin instead of troponin. Troponin is absent. So instead of troponin, it binds with the calcium, it binds with the calmodulin, and this will activate myosin light chain kinase. Usually the myosin head will be having inbuilt ATPase. It will be having inbuilt ATPase in skeletal muscle, but here it should be activated by myosin light chain kinase. So phosphorylation of myosin will occur, and once this phosphorylation occurs, our myosin ATPase is activated. Then the cross bridge formation occurs and then contraction occurs. The difference in the skeletal muscle is there is troponin in skeletal muscle and there is calmodulin in smooth muscle. Skeletal muscle myosin ATPase is ready-made active. Here it requires phosphorylation by myosin light chain kinase. These are the two prime differences between skeletal and smooth muscle. And also the source of calcium is ECF in smooth muscle and it is sarcoplasmic reticulum in skeletal muscle. Coming to the relaxation of the smooth muscle. So the relaxation of the smooth muscle occurs by the dephosphorylation of myosin light chain by the enzyme myosin light chain phosphatase, and the smooth muscle doesn't go into relaxation immediately. It will be in a latch state or latch bridge mechanism. The relaxation will be also slowly occurring. So the contraction is slow and even the relaxation is not abrupt. It will be also extending for a longer duration slowly. And also smooth muscle get relaxed not only with the contraction, not only with the myosin light chain phosphatase, with some chemical like acetylcholine. It binds with the G protein linked receptor that causes inositol triphosphate, which causes the release of calcium from endoplasmic reticulum, that binds with the calmodulin, and this calcium calmodulin will activate as myosin light chain kinase. That's a different story. And also it activates nitric oxide synthase, which synthesizes nitric oxide, and this nitric oxide enters the smooth muscle cell and will cause the activation of guanyl cyclase, which converts the GTP into cyclic GMP, which activates the protein kinase G, which causes muscle relaxation. So muscle relaxation not only after the contraction also occurs with the help of a ligand. And already we mentioned some features, we will mention still more features of smooth muscle. There is a latch state or latch bridge mechanism. It undergoes a state of contraction and also relaxation. Even the stimulus is over, it will remain in a contracted state for a longer duration. So with less utilization of energy, it can remain in contracted state for a longer duration. Slow contraction and slow relaxation. And as we already mentioned, the corkscrew like contraction, more shortening in the length, almost 80% shortening in the length comparing with the 20% in skeletal muscle. And the durations, because of the longer action potential durations, the twitch durations are also longer. And there is no length tension relationship. What is this length tension relationship? Let's think that a muscle is stretched. More the stretch within the physiological limit, it contracts with more force of contraction. Okay, but smooth muscle will adapt to this new length and it will be the zero length from it now. If you stimulate it now, it contracts as it was prior in the resting length, so it adapts to the newer length. We call that as plasticity. So that's why it doesn't follow length tension relationship. And it has a feature of stress relaxation. What is this stress relaxation is If a smooth muscle is stretched for a longer duration, it undergoes relaxation. It undergoes relaxation and we call that as stress relaxation. And the tension generated in the smooth muscle is almost 4 to 6 kg per square centimeter, comparing with a 3 to 4 kg per square centimeter in skeletal muscle. And coming to the comparison between these three, we already know that smooth muscle has very small action potential duration, and also the twitch duration is 7.5 milliseconds in fast muscle and 100 milliseconds in slow. Whereas cardiac muscle is 300 milliseconds, smooth muscle is 1000 milliseconds, almost duration with the action potential. And all-or-none law in skeletal muscle is followed by single muscle fiber, not all as a whole. Whereas in the cardiac muscle, as it is a syncytium, whole muscle, single unit is also a syncytium, whole muscle will follow all-or-none law, multi-unit single muscle fiber will follow all-or-none law. Fatigue is possible because of a shorter refractory period, whereas it is not possible in cardiac. It is possible but not able to, we can't demonstrate in smooth muscle. Quantal summation or multi-motor unit summation, with increased strength of stimulus, more motor units will be recruited. That's why we said skeletal muscle as a whole does not follow all-or-none law, because there is recruitment. So it is possible, and such thing is not possible in smooth and cardiac. Tetanus possible and not possible in smooth and cardiac. Length tension relationship, optimum length, maximum tension, and optimum length in the cardiac muscle is end-diastolic volume, and smooth muscle doesn't obey length tension relationship because of the property of plasticity. Blood supply, as skeletal muscle is having a wider area, the blood flow as a whole is more, 840 ml per minute, but 100 gram tissue it is less, 3 to 4 ml. Whereas heart, it is 250 ml per minute, but per 100 gram tissue 80 ml per 100 gram. And the smooth muscle is 350 ml per minute, but 100 gram tissue it is 1.4 ml. So maximum blood flow as a whole is skeletal muscle. Maximum blood flow per 100 grams is cardiac muscle, and lowest is smooth muscle.